In this video, we're going to find the derivative of each function given here, and they all involve an inverse trigonometric function. And here are the formulas that we're going to use. Derivative of arcsine is 1 over the square root of 1 minus u squared multiplied by the derivative of u with respect to x. U generally will be a function of x. Notice for the arc cosine, it's pretty much the same formula, except it has a negative. Arctangent and arc cotangent, same formula, 1 over 1 plus u squared, multiplied by the derivative of u with respect to x. Arc cotangent, same thing, except it has a negative. You can see the one for arc secant and arc cosecant, same formula, except one has a plus and the other one has the minus. And again, du over dx can also be represented by u prime, abbreviated form there. So for the first one then, we'll just denote the derivative. We can write it as dy over dx or just y prime. Same thing. So it's the same thing as derivative of y with respect to x. So this is going to equal to, and this was 1 over 1 plus u squared. Now in our case, this represents the u. So if you square that, you get 9 x squared. And then it was multiplied by the derivative of u with respect to x. Well, this is u. Derivative of that would be 3. So it's times 3. So we'll write it this way. Y prime then will equal to 3 over 1 plus 9x squared. Now the second one involves the arc sine function. So this will be y prime. Remember this one had a 1 here, and then it was over the square root of 1 minus u squared. In our case, this is u. So if I square it, I get an x. And then it was multiplied here by the derivative of u. So think of the square root of x as x to the 1/2. So if I take the derivative of that, the 1/2 comes out in front here. And then we subtract 1 from the 1/2, we get a negative 1/2 for an exponent. So this is going to equal then to 1 over, then we're going to have this 2 here in the denominator. And this comes to the denominator, changes the sign of the exponent, so this can be written as x to the negative 1/2 in the numerator can be written as the square root of x in the denominator. And that's times the square root of 1 minus x. And then the final result then would be 1 over, got a radical and a radical, so I can multiply through. This would be the square root of x minus x squared. And that's the solution for that one. This one is the arc cosine. So y prime then, or dy over dx, will equal to, and then the formula for this one was a negative 1 here, instead of a positive 1 for the arc sine. And that was over the square root of 1 minus u squared. So I had a u squared right here. In our case, the u is 1 over x. So I can write this as 1 over x squared will give us that. And then it's times the derivative of u, which is 1 over x, which you can look at that as x to the negative 1. So bring the negative 1 out in front. Subtract 1 from the negative 1, you get a minus 2 there, x to the negative 2. So then this is equal to the negative here is positive, make this a 1 here, and then take the x to the negative 2 downstairs here, the denominator makes it x squared. And this is going to be the square root of, I'm going to rewrite this, putting this under one denominator, multiplying by x squared and x squared here. This thing would be x squared minus 1 over x squared. So I just wrote this under one denominator, over one denominator. I'm multiplying here by x squared and x squared. And then here I can just take the square root of the numerator and denominator, so the numerator is going to stay the square root of x squared minus 1, but the denominator, the square root of x squared, can be written as absolute value of x. And I can also write the x squared as absolute x times absolute x. That's going to cancel this over here and leave me with 1. So for the final result here, I can write this answer then as y prime would equal to 1 over, I have absolute value of x from reducing right here, multiplied by the square root of x squared minus 1. And that's the solution for the derivative for number 3. Okay, so number 4, take the derivative of that to be y prime, and when we have the arc sine of x plus the arc cosine of x. And remember, those were identical. The only difference was the sign. By that I mean plus minus, okay? So the derivative of arc sine of x, remember, was 1 over the square root of 1 minus u squared. Well, in this case, the u is x. So we get this. And for the arc cosine, it was the same thing, except it was a minus. So this is a plus here. So this is a plus from there. And then for arc cosine, the formula for the derivative of arc cosine was a minus 1 here over, and the derivative of u, this is u right here, is 1. So it's going to stay minus 1. And then it was the square root of 1 minus u squared. Again, x and u are the same in this problem, just like in this first part. So this was x squared. 1 over the square root of 1 minus x squared plus minus 1 over the square root of 1 minus x squared. This is going to be 0. So that's the solution for number 4. Now for number 5, let me simplify this first before we take the derivative. So I have y is equal to, going to multiply through by the 1/2 here. That could be 1/2 times 1/2 will give me 1/4. And then I'm going to break up this natural log using one of the properties of logs. If I have a log, in this case natural log of a fraction, the same thing as the natural log of the numerator minus the natural log of the denominator. So that breaks it up that way. And then I have the 1/2 times the arc tan, so this would be a plus here. And I still got parentheses for this one here. And then this arc tan will be multiplied again by the 1/2, so this would be 1/2 arc tan. Of course, that's your tangent. Still haven't taken the derivative. I just simplified this. So this is the same thing as that. Now I'll take the derivative. So with the derivative of this is a constant, remember, so I can just take the derivative of what's inside and then multiply by the 1/4. So the derivative of this natural log is given by simply putting the 1 plus x in the denominator, and the numerator is the derivative of this expression here, 1 plus x. That's the derivative of 1. That, of course, is also multiplied by the 1/4, so to give me 1 over this, 4 times x plus x. Same sort of thing over here, except I have the minus. In this case, then this will be 1 minus x goes in the denominator, and then the derivative of the numerator is a negative 1. 1 has a derivative of 0, minus x has a derivative of negative 1, so we get that. And then that's times the 1/4, so we just put a 4 here then. And then over here, for this one over here, I just put a plus here. And the derivative of arctangent, remember, was 1 over 1 plus u squared. In our case, u squared is x, so or u rather is x. So u squared would be x squared. The derivative of u, in this case x, is 1, so it stays like that. And still got the 1/2. We switch the 2 here in the bottom. Okay, this minus here will make this minus there a plus, so let's just put a plus here. And take that off. Now we just combine here. So to get the same denominator, we simply multiply by the first one here by 1 minus x, and the second one here by 1 plus x. So the LCD then is 4, 1 plus x. And let me write this then, because I'm going to have to combine it with the second part here. So these are going to be multiplied to get the same denominator. So I multiplied this one here by 1 minus x. Numerator and denominator got 1 minus x squared in the denominator. This one I multiplied by 1 plus x, numerator and denominator, and I got the 1 minus x squared. On top I got then 1 minus x for this one, and for this one was 1 plus x. Minus x and x cancel, and 1 and 1 is 2. So that gives me a 2 right here. And then I've got plus 1 over 2, and then it's 1 plus x squared. This one we can reduce. 2 goes into 4. 2. Give me a 1 in the numerator and a 2 in the denominator. So we got a 2 on top and a 4 on the bottom. Reduce it down to 1 over 2 times this product here. And then the next step then, let's have to combine. So we're just doing the algebra here. So we need the same denominator. So I'm just going to put 2 here. And I'd have to multiply this one. I'd have to multiply this one here by 1 plus x squared. The numerator by 1 plus x squared. And over here, multiply this one by numerator and denominator by 1 minus x squared. And then the bottom here by 1 minus x squared. So this would be 2, and then the 1 minus x squared times 1 plus x squared, and the same sort of thing here gives me 2 times 1 minus x to the 4th. And notice here in the numerator I have a 1 times 1 plus x squared, a 1 times 1 minus x squared. So I'm left with 1 plus x squared and 1 minus x squared. But the x squared and minus x squared cancel and I get a 2 here. And this 2 can be canceled. So I'm going to get 1 over 1 minus x to the 4th. Delete these then. So that's your final answer for that one. 1 over 1 minus x to the 4th. Thanks for watching. We'll see you next time.